Welcome to another edition of Math for No Reason. In this edition, we are examining this problem. We want to find the number of solutions in non-negative integers that is there for this equation x1 plus x2 plus x3 plus x4 plus x5 equal to 13. There are many ways in which this problem can be solved, but I will illustrate this using the method of generating functions. Now, what is a generating function? Let A0, A1, A2, A3, etc. be a sequence. The generating function of this sequence, which we denote by Hx, is this function A0 plus A1x plus A2x square plus A3x cube, etc. So, in general, Hx can be written as summation of n is equal to 0 to infinity a n x power n. This is called the generating function of the sequence a n. Now, how can we use this for this particular problem? Now, for that, we use the generating function of the sequence 1, 1, 1, etc. Or in other words, an is equal to 1 for all n. Now, what is the generating function of this? Now, for this, Hx is 1 plus x square plus x power n, etc. So, this is 1 divided by 1 minus x by using the formula for the sum of an infinite geometric progression. Now, consider this product of 5 terms, and suppose we are trying to write this in an expanded form. So, what is the power of x power n in this expansion? X power n will be created by taking terms xm1, xm2, xm3, xm4, xm5, where xm1 comes from the first bracket, xm2 comes from the second bracket, xm3 comes from the third bracket, xm4 comes from the fourth bracket, and xm5 comes from the fifth bracket. Main property is that if we are summing up m1 to m5, then we must get n. So that is the defining property that we have. Now, the number of times this occurs would give us the count of the number of solutions in non-negative integers of this equation. It will also give us the coefficient of x to the power n. So, if we can find out this coefficient, then we will get the solution. So, let us try to find the coefficient. So, writing this expression as 1 minus x, we have 1 minus x to the power minus 5. So, what is the coefficient of the nth term of this? So, let us try to find that out. Now, by the binomial theorem, this is 1 plus minus 5 into minus x plus minus 5 into minus 6 by 2 factorial into minus x square, etc. And the term corresponding to x to the power 13 will have. So, this is the term that we are interested in. So, that is the number of non-negative integer solutions of this equation. We can simplify this to write, now the coefficient of x to the power 13, this term is what we are interested in. So, the answer to this is 17 into 16, etc. up to 5 divided by 13 factorial. In other words, this is 17C4. So, this is a good point to stop. Thank you.